All right, so here we are. We're at packet 5, class number 14. And it's a Monday before break. And today we're going to spend most of the time on 1D conservation of momentum. Looking at what's happening, there's last week. Got all the grades in, as I was telling them before we started recording. So there are, I think I'm going to do it this way now on. There are 3 ways to turn things in. And this will probably apply to anything. One will be through the classroom box. One will be my front porch. And one will be submitting it on Canvas. Okay. So that's how to turn in the test 4B. Now I screwed up on the test 4B, black and blue. And I put it there, but I never showed, you never had a place to put it. There was a place there, but that was already taken up by the 228 points. We needed another slot. So that's why I said, okay, if you didn't turn it in, I'll let you turn it in up till tomorrow night and not lose any points. This is black and blue, black and blue. Okay. Most people have turned, 90% of people turn it in. This is this week. Wednesday, well, it doesn't matter to you. Same schedule for you all the time, 1:10 to 2 o'clock. But the big day is Thursday. For you all, it's actually going to be well, I don't see why I couldn't for virtual. Okay, so for virtual students, we'll make it so that emailed, the PDF of the test is emailed to you by, we're not going to meet that day in here. So I'll give me time. I'll give you time to set that up, and I'll email it to you by 2 p.m. 1:30 p.m. 1:30 p.m. And then thing is, it's due by midnight. Okay, due by midnight for you all that night, because we're not meeting, no one's even there at school on Friday. So there's no reason to push you back to Friday. You might as well just do it that afternoon. It'll cover 5.1 through 5.5. It just covers the practice problems. And by the way, somebody noticed that the last practice problem and I think the 8th practice problem, they're the same. I didn't realize that. Thought they were slightly different, but they're the same. So just do one of them. That means we're down to 11 practice problems. And of those 11, probably I'm starting to work on tonight. So probably around, and it's easy to make these up because, right, I'm dragging and dropping. I drag over from the practice problem onto the test, boom, problem done, change a few numbers, slightly change situations, but I want that thing to look like your practice problems so that you are rewarded for all the work you do, okay, in preparation. So there'll be no surprises, no extra problems I throw in. I'm not gonna get cute by half and try and mess you up. It's gonna be those problems. They're hard enough. And there'll be probably 7 of them, somewhere in there, 6 to 7 of those problems. And you'll give yourself an hour. As you do, I know a lot of you are very honest because you could, I mean, like Ellie, I'm looking at Ellie's and she'll leave a couple of them like blank. And I know she's being honest because she said I ran out of time. That's integrity, right? I mean, integrity is something when no one's looking, you're still honest because you know that the main thing is yourself. You got to be honest with yourself. You got to sleep at night. Okay, so we all rationalize, well, I did it because of this. No, come on, man, be honest. You cheated. But I don't, I feel pretty good about you guys. And then there's nothing, I traditionally give nothing over break. I hate those teachers who give, here's your homework. Ugh. No homework over break. Don't even worry about physics. And then we'll do a flex day after break on this test. On the flex day, we'll do a blue day. Okay, we'll talk about that more here. All right, so that's what's coming the next couple of weeks. Today I did a dyno hunt. I was looking for 5.53 and 5.4, the whole back. They had to have those done. So you ought to keep up with these dyno hunts because that's where you should be. The question is, will 5.5 be something you turn in? Probably. How about we just say yes to that? So for virtual, we'll make a decision here. Virtual 5.5 will be due. When? They have to turn in, they're doing 5.54 to now. We did 5.56 together. They got 2 more to do, Monday, Tuesday. And so let's say then for you all, 5.5 is due, the virtual 5.5 is due Wednesday night. Due Wednesday at midnight. That means I've got to put it into the canvas. So 5.5 due Wednesday midnight. It's going to be worth some good points because we got to try and get the same points they got. Do I hear that? Thumbs up. You heard that. Thumbs up. Okay, lots of thumbs up. Good. So we're talking pencil that in. You'll get the assignment, but it's Wednesday at midnight. I'll send it out tonight probably. 5.5 is due for virtual. I handed back all their notes. Your notes and your packets are in the folder or in the this folder like this, right? On the front porch. Although I warn you, I pulled that folder out on Saturday and all the papers went everywhere because it just fell open and then slid everywhere. So be careful when you open it up inside the box so it doesn't all fly everywhere. But like Jacqueline's, there's no name. I didn't have these things, you can't move them around. It's real hard to take the little name out. So Jacqueline being Vaughn makes sense just to put her at the back. And Evan's in there too. There's a McCracken in there, but you got to kind of look for it. It's in red. And looking up here, everybody else is in there probably pretty much in order. Anthony, I'm not sure. Yours is in there somewhere, but because anybody that came late, I mean, quote late. So you're still in there, but so that's, sensitive information, which I would consider your test and stuff like that, your packet. No one else should have to see that. Your notebook, they're all in there. Okay. So if you turn them in that way, that's great. If you emailed them and you PDF'd them, turns out that was really easy to grade. I was worried that I was going to get, with 11 sheets, I'll get 11 pictures. Oh my gosh, it's going to be a nightmare downloading all this. But those that did send in their packet through email. And then I think Bennett, it wasn't Bennett. Who was it? Somebody that did it. Oh, Anthony did it as a Google share, which worked just as well. That's fine too. You can share it with me on Google. But those that sent it in as a PDF, and then they attached it all in one attachment, easy open up, slide, check. The only thing I can't do is I can't write on it. So you get a score. It's out of 125 points. You get 110. You go, whoa, what did I miss? It's there. I promise you. I've read through it, and there was things missing. If you really want to know, I can talk to you about it later. That's the only problem with emailing stuff, is I cannot handwrite on there. Maybe next year everybody have iPads and we can do it that way. And I can grade it to an iPad. I don't know. I'm not an expert at Canvas. Did our joke Monday. Okay, there's those. These two are identical, it turns out. So I think you have more room on the last one. This one, 15, is identical to 8 to, Yeah. To 12. Practice problem 12 is the same as 8. So probably just mark that one out. So that still gives you up to 11 dynos. Well, you don't have dynos, but for you, it's just points. That's still 33 points you can get and it's dynos, so it's like sort of bonus, sort of not. If you get to it on dynos, if you get to 30 dynos, then everything past that is bonus. And so for you, if you get to so many points on submitting stuff, then anything beyond that, anything beyond 90 points of submissions will be bonus for the semester, which comes in real handy. I'm just looking at grades. I have 73 students. 11 or 12 right now have above 100%. A lot of them are you guys, have above 100%. And so that's most I've ever had. I've never had that kind of high scores, but it's because some of you are taking advantage of everything, and some just, I'm trying to find ways to keep people's head above ground, above water. And then those of you that are just saying, okay, I'll do that. And now you got 105%. It's crazy. Tomorrow in class, I'll do this demo. This is for gliders. We're doing collisions now. So head-to-head collisions. This is the linear track. We spent about $5,000 in this way back. Like in 1999, 2000, we spent like 5,000 because back then it was like real expensive technology. Now you can buy the whole thing probably for 1,500, but back then it was a lot of money. So we'll talk about this. This was my attempt to get really good data on collisions, and you'll see why tomorrow that was fruitless. But okay, so our goal for the rest of this time, for the next 30 minutes, is to finish as much of the front as we can. Okay, so all of this. Now, number one is homework. They're getting two dyno, one dyno for that. Number two, we'll do together. For us, we'll do 2 and 3 together. 3, I'll kind of send you to the board. And 2, let's just work together. So we went through the different equations for collisions. Now, this is class, those that have been struggling with all this chain rule and power rule and all this complicated functions and derivations, that's all done for now. We don't have to worry about that. We'll never have to worry about chain rule again this semester, but power rule comes back off and on. But as far as the math on these is just simple pre-algebra, basically, really simple math. There's no squares, there's no square roots, there's nothing weird. So that's good. The physics is pretty obvious. Things hit and they collide. They stick or they bounce off. You know, they're going this way. There are some areas, and I'll point those out, where people have trouble here. Usually conceptually, they're okay. It's just some detail they get screwed up on. All right, so let's carefully, number one is you're on your own on that. I'll let you work that. But number two, let's do that one together, and we'll do it very slowly, very carefully. Okay, so gliders. Now these are gliders like what we're going to do. You can see them there. There's 3 gliders. I was holding them up in class today. There's Gold Wing, there's Red Dog, and there's Blue Boy. And those are kind of like the gladiators. And then, whoa, look at that. This was taken last year. Look at that. Huh. Telltale sign, man. It must have been, we must have known. Oh, in my class, we got Dr. Clevenger came in and talked to us on January the 30th about COVID. We knew about COVID way before anybody else. We were cleaning everything up. So we were already wiping everything down back in January. And then the rest of the country caught up in March. Right. Anyway, that, or I don't know. That looks, he graduated a while back. So maybe that's not true. This may have been taken a couple years ago.
Was that Josh Dennis?
Yeah, that's Josh. I didn't know you knew Josh. That's who that is. He'd already graduated. So this couldn't have been from last year. I'll see it 2-3 years ago. I don't know why that's there. I thought I noticed something. Okay, here we go. So first off, let's do kind of a CL-DEPA thing. Okay, so I'm gonna go red and blue I'll go Red Dog and Blue Boy. So Red Dog is the smaller glider. And so I'll make, since that's 60 grams, I'll make that Red Dog. So I'm going to circle that one. 60 grams, that's just M1. Moving, so anything involving that one, I'll make red. Moving at 40 centimeters per second, so that's V1 naught. On a frictionless linear track. And so air tracks have other problems, but friction is not an issue. Is on a collision course with a 300-gram glider. I'll make that Blue Boy. So that's M2. Traveling in the opposite direction, double check opposite, underline that, direction at 125 centimeters per second. So that is V2 naught. And you got to be patient with these. Don't get in a hurry to start throwing numbers. That right there is the mark of a rookie physics, of a physics freshman. They just take it and they start throwing numbers at equations because they just can't discipline themselves to slowly work. And then you'll be surprised, slowly get to that drawing on a homework. On tests, you'll be faster, but on homework. Get to that drawing, enjoy the drawing, find out all the stuff there, then go to your equations. Their bumpers engage in a perfectly elastic collision. Okay, so it's elastic. That's an important word. And the 300-gram glider continues in its original direction with a reduced velocity of 80 centimeters per second. Okay, that would be then my V2 final. What is the new velocity of the 80-gram glider? So they're asking me for what is V2 final, V1 final, sorry. What is V1 final? Question mark. And it says this is, okay, so I kind of gave it away, but I was going to ask, we have three, remember, when you're working problems, you always have three choices for systems. You have CGS, you have MKS, and you have FSS. CGS, centimeters, grams, seconds, MKS, meters, kilograms, seconds, FSS, feet, slugs, seconds. Well, this is probably 75% of the time. This is about 5% of the time. This is about 20% of the time, in my class anyway. But in this case, it looks like it'd be much smarter just to keep it in CGS. All right, so now let's go look at the drawing here. And these are panel cartoons. So these are two panel cartoons. If you look at the bottom one, go flip over to the back of your page here on the back. Look at this number 8. That's a 4-panel cartoon. So our drawings are becoming more complicated now because we're looking at situations, before collision, after collision. So here on this one, we start off with a fairly simple one, but JBC means just before collision. JAC, just after collision. So then I mean the microsecond before, all right? So JBC, let's draw it here. So we got the red one, Red Dogs coming along. It's just a dot's fine. We don't really start drawing extended bodies until we get into torque. So for us, it's going to be May because we're so far behind, and then a lot in June. But so, so I'm not going to put all the numbers. I have my numbers. I'm just put the units here. I mean the symbols. So that's M1. V1 naught, and then I got Blue Boy coming along, cruising along here, much bigger and much faster. I mean, Red Dog's got no chance. So here we have M2, V2 naught. That's going to be a bad collision for. Thing is, these are like Rubberman. This is like they're bumpers, and so they don't stick. It's not like two lumps of clay. They hit and bounce off. And we're assuming it's perfectly elastic, which really in nature doesn't exist, but more about that later. So that's the beginning situation. The final situation is Blue boy continues in the same direction at reduced speed. So it continues to move that way. This time the arrow is not quite as long. V2 final, M2. And then obviously, red dog must be, they didn't go through each other. So red dog is going to gain a bunch of speed because what it lacks in mass, it has to make up for in speed. And so there's M1. And then we have, the question is, what is V1 final? Question mark. Everything else forgiven. Okay, and you start writing all the numbers in there, it's going to get really messy. So now, obviously, the equation we're going to use is the highlighted one there, the elastic collision. So let's just now very carefully, I'm going to do this, but I'm going to make two mistakes. Okay, now wait, don't tell me what they are until I'm done. But then hit your finger on the button so you can get the points here. But let me make the mistake here. Two mistakes. Okay, so now we go along. And I don't need, you don't need to write the symbol equation out. Just go ahead and stick in numbers now. And normally we isolate the variable, but you'll see why we don't do that. And on these, only in this case, do we not isolate variables. Everything else, we should first isolate the variable. 60 grams, 40 centimeters per second. The first time you write the equation out, you need to have the units. Plus that guy is 300 grams. Blue boy, 125 centimeters per second.
Shouldn't its velocity be negative?
You were waiting to pounce, man. I was planning to get to the whole thing first. Okay, you're right, though. That is the number one mistake students make on these problems is they, for some reason, ignore their signs. So you've got to look at it and say, okay, that's negative. Otherwise, obviously, you're going to be really a real problem. So back here on the drawing, I will put this sometimes, a little marking up there to put a plus just to remind me anything to the right is positive, anything to the left is negative. Okay. That's a good warning. Because even though you're chugging along, you're in a hurry on tests, especially, that's something you tend to forget, and then you wonder why your answer is not even close. Okay, so then at the end we have, after the collision, we have 60 grams. We want to know what this is, V1 final, plus 300 grams. And then we're given this at 80 centimeters per second. Someone gonna chime in?
Isn't the V1 final negative again?
Yeah, Sophia's name lit up, but then she couldn't get in. She got blocked. I've never seen this. What's this show where they do the singing thing? And then last night, someone tried to turn around. There's this one singer who's real good. And then John Legend got blocked. What is going on with this show? Anyway, then I turned channels. So yeah, that's got to be negative. Okay. So there. Oh, sorry, finished product. Nope. Here we go. All right, so there. This is okay. So this looks like it violates one of my rules, and one of my rules is you keep it in symbols, and you isolate your variable. You box that in. Remember CLDPA? The I stands for isolate your variable. Finally, the P stands for plug in. But we violated that rule. We didn't isolate the V1 final. Now, when I first started teaching this, back in the 80s, I did make them isolate. And over again, year after year, I fought this. Kids got their signs messed up. And it's bad enough here trying to get the signs right. But then when you manipulate your equation and you algebraically, then you're having to remember, wait, that's a negative 80. It's easier here to keep your signs straight. All right. And that signs are the number one mistake students make with conservation of momentum. Sign, sign, everywhere a sign. That's Five-Man Electrical Band, 1970s. Great song, you should look it up. And the sign said, you've got to have a membership card to get inside. So I took all the hair, no, so I put all my hair up under my hat and I went in to ask them why. Oh, it goes on and on. Well, the rest of it is multiplying, adding, subtracting, you know. So let's cut to the chase. The next page, I'm going to cheat. There's the answer, negative 185 centimeters a second. So V1 final, and you can, you know, hear me now and prove it later, is negative 185 centimeters per second. Now let's go, wait, does that make sense? Look what happened. Let's step back now. Look at this from 10,000 feet. So this guy's coming along, Red Dog's coming along, Blue Boy is barreling at him. Blue Boy is 5 times the mass of Little Red Dog. So you can expect this is not going to go well for Red Dog. So comes along, Blue Boy comes along screaming in. Not only is he 5 times more massive, it's moving at over 3 times the speed. So this is a disaster. So it makes sense that Red Dog would turn around and hightail it the other. Once they collide, get smashed back the other way. Its speed goes from 40 to 180. So we're talking 4 or 5 times, almost 5 times the speed pushed back the other way. It's like that poor gerbil or hamster, whatever it was. That hamster we saw on Friday where she bounced the ball and the hamster went flying. That's what happened to Red Dog here. Okay, that's all there is to it. I'm telling you, today, tomorrow are some of the easiest physics we do second semester. We have a little respite here. Wednesday, it's going to start to climb that hill again. We're going to start to get hard again on Wednesday. And then the week after spring break can get difficult because that's all two-dimensional collisions, which then leads us to glance ball, which is fun. But then that leads us to finally duck walking. And duck walking takes us to F equals MA and all that stuff. And then that takes us to free body diagrams. And then finally we're on our path for the free body diagrams, takes us to everything else we do the rest of the year. So we're getting there. But now at least we're finally bringing in mass into the situation. Kinematics is the study of physics without the mass. It's just all what happens to the mass. Now we're bringing in the mass. Okay, so there's that one. Now we got 15 minutes, perfect. I've told enough stories and sung enough songs. We're in good shape. Number 3, that one went to the board on. So what I'm going to do is I'm going to hit pause. And you're going to go work on that one on your own. Before we do that, though, hold on. Before I send it to the board, we talked about it for a minute. So let's talk about this. Here we got, okay, this is another famous problem in physics. It's a category of problems in physics. And this category is called bullet block. These are bullet block problems. Okay, hold on. These are bullet, and you're going to have, this is the simplest possible. This is like the Barbie doll that comes in the package, and then you could, make it airline stewardess Barbie, or you can make an engineer Barbie, and you can make it, banker Barbie, and you can do all these little things. You can add, you can modify it. Well, this is the generic simple problem. And then, okay, so this is called bullet block, or sometimes it's called ballistics. But ballistics is, back in the FBI days, they would take a gun that was in a scene, they would shoot it into a block that's hanging on a pendulum, and the block would rise, and by how far the block rose, you can determine potential energy. And from there, you can figure out the the point was you could finally figure out the muzzle velocity of the bullet, and that would help him on the CSI for the crime anyway. But it's called bullet block problems. And we have, this is the simplest possible situation. We have a block, it's a lump of clay. It's sitting on a table, horizontal, there's no angle to it, nothing like that. And a bullet is shot into it. So we start off with, this is also called big B, little b. So my mistake. This should be a little b. The bullet's the little b, the block's the big B. So this is M little b, this is M big B. Bullet block equations. So you'll hear me say that. I'll say, okay, guys, this is bullet block. But they get harder because, like in AP physics, you'll have a block sliding down an inclined plane with friction, with air drag, and then a bullet is shot up the inclined plane into the block, and it goes through the block, and then, you know, all these little things happen, and that's the AP physics test. We'll always have one of these crazy bullet block, or it's on a pendulum, and the pendulum's attached to this other lever, and it makes the thing go up, and then the lever, like a, you know, Rube Goldberg, and then you got to work your way through it, and that's a machine problem. But bullet block, here's your, you should mark this in your calendar, the first bullet block problem. Okay, and if your parents are in physics, we did some bullet block problems today. And I'll make my block blue clay. I'll make my bullet, the little guy, red. So here comes the bullet. Now the international symbol for movement, there's my bullet, is 3 lines. Looks like that. So the block doesn't have any of those 3 lines, so the block's not moving, the bullet's moving. And then that's the just before collision. Just after collision, the bullet embeds itself inside the block, and now the block itself, the combo, moves. Okay, so that's sort of the scenario. Sometimes the block is moving towards the bullet when it happens. You can handle all these. Now, the next question on this one is, before I send you to the board. Next question is, looking at what I'm given, the block's my blue. So 4 kilograms, the bullet's red, 8-gram bullet. And then the speed is 570 meters a second. That's not that, that's pretty fast actually for a bullet. That's pretty fast. That's approaching Mach 2. So that's a fast bullet. See, what the bullet lacks in mass, it makes up for in velocity. Here's the question. Should I do this in CGS or MKS?
CGS?
I'm not saying you're wrong. The problem, and you could certainly work it correctly using CGS. The problem with CGS here is you got to convert that to 4,000, okay? You got to then convert that to what, 57,000 centimeters per second. And now your numbers are getting big, and it doesn't seem, you could do it that way, but I would choose MKS, okay? MKS. Okay, so it sticks in it, meaning there's no splinters, all mass is now combined. The block with bullet then slides along the ice until it stops. Don't care about that. That's a whole other problem which we'll do, which now determine the coefficient of friction between the surface and, you know what I'm saying? But that's not part of the problem. The problem we only care about is just before impact and just after impact. So you can get mad at me for saying this because you're going, well, that's messing me up. That's not necessary, not needed. But for this particular problem, that's not needed. And tell you the truth, if I was writing this problem today, I probably wouldn't have written it that way because I can see where that would. I'm not trying to confuse you yet. No, I'm never trying to confuse you, but you do want to give students accused professors of confusing him. He was trying to confuse us. No, he's trying to give you a situation, or she is, that you're have to think through it. Well, which of my 4 equations is this one?
The second one.
Yeah. So bullet in blocks was the second one. So now you're going to go, I'm going to turn this off. I'll turn the recording off and you're going to work it. Okay. Pause. All right. So they've been working on this and now hopefully you have at home as well. And so we've established it's going to be an inelastic collision. So we're going to be an MKS system. So we have, initially we have the 8 point. Now it's for the bullet. Now it's 0. I'll go red. It's 0.008. 008. Lost didn't say 0.08. Dang it right. 0.008 times 570 meters per second. And I'm making to the, I've established, and this is kind of a given, but I've established that to the right is positive. Now the bullet's got nothing, so that's a plus 0. And then that equals, now we combine the two. So now we have, you go, so someone in class say, well, wait, you mean the bullet, the block has nothing to do with it? No, not initially it doesn't. It has no momentum to begin with. Equals, and now we combined them. So what there? I guess I'll just make it black. Plus 4.008, because now it's a combination of the two masses, times what I'm trying to find, the combo being black, is V final. That's it, right? That's it. So, and then whatever V final is. Time to cheat. 1.14. 1.14 is what I got. Did you guys get that? Equals positive 1.14 meters MKS, meters per second. Okay, well, 1 meter a second is about the speed at which we walk. So we're saying that block was sitting there, a bullet comes screaming in at almost Mach 2. Mach 2 is 660 meters a second. So getting up there and slams into that clay, and then the whole thing slides along at about the speed a person walks on a frictionless surface. Well, no, it wasn't frictionless. Then it comes to a stop. So if this is later on in the semester, we'd say, and then now determine the coefficient of friction between the floor and the bottom of the clay. But that's a different question. But that's going to be the initial, that's the final velocity of the collision, which then would be the initial velocity of the messing with friction part. Okay, so your homework then is simply to do number 1, work on that on your own. We can talk about tomorrow if you want to. And then your other homework is to work on number 4 if you're going to keep up with it, because this is now, as we said, this is now due Wednesday at midnight for virtual kids. The whole front of 5-6 basically should be done, and I'm offering them an extra dyno to make sure that's good. 27 dynos, which 27 times 3, what is that? 80 something. 81. So 81 points. We've already done one or two submissions, but the whole submissions we do are going to add up to around 81 or 85 or something. So that makes this one worth quite a bit to get 5-5 done and submitted. Okay. That's it. Oh, that's a coming. That's what I'm saying. The class gets harder on Wednesday. Tomorrow we'll do the back of this one, 5-6. It's not that bad. It's a little more, there's a few more things, but and then we'll look at the demonstration of the air track. But then Wednesday, here comes that. Remember, none of this stuff though is on the test Thursday. It's just involving projectile motion. Okay, so I am now going to stop the recording.